Spice Math. That's right. You add it up, multiply it, man. Spice Math. Okay. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Erin Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hey there guys, welcome back to another episode of Spice Math. In this lesson, we are going to be looking at solving the linear inequation part 2. Now this lesson is catered for forms 3 to 5. Let's take a look at our objectives for this lesson. Here are our objectives. Read with me. 1. Solve linear inequations by multiplying both sides by the same positive number. 2. Solve linear inequations by dividing both sides by the same positive number. 3. Maintain the truth of an inequality when it is multiplied by a negative number. And 4. Maintain the truth of an inequality when it is divided by a negative number. Now let's have a recap. In our previous video, we identified the different features of linear inequations. We solved linear inequations by adding the same quantity to both sides, as well as we solved linear inequations by subtracting the same quantity from both sides. Let's get right into it. We can solve linear inequations by multiplying both sides by the same positive number. For example, we have x over 2 is less than 5. Multiplying both sides by 2, we get x over 2 multiplied by 2 is less than 5 times 2. When we simplify this, we can see that 2 divided by 2 would leave us with 1. Therefore, we have x. And we have 5 multiplied by 2, which gives us 10. So, simplified, we have x is less than 10. But of course, we cannot leave our answer like this. Our answer must be represented as a solution set. Hence, the solution set is the set x is such that x is less than 10. Let's try these. Solve the following inequations. Okay guys, so here we have our first inequation to solve. Read with me. Y over 7 is less than 0.5. So we're going to solve this inequation, meaning we're going to solve for y. In order to do so, we are going to multiply throughout by 7. So when we do that, we get y over 7 multiplied by 7 is less than 0.5 multiplied by 7. When we simplify this, we're going to get y, because 7 multiplied by y would give us 7y divided by 7. And 7 divided by 7 gives us 1. Therefore, we're left with y. So we have y is less than 0.5 multiplied by 7 gives us 3.5. Now remember I said we cannot leave our answer like this. We must represent it as a solution set. Therefore, our answer is the set y is such that, and such that is represented by the colon. So the set y is such that y is less than 3.5. Now let's go on to our second example. So here we have our second example. Read with me. X over 3 is greater than or equal to 8. Now we're going to solve this inequation by multiplying both sides by 3. Remember, we are solving for x. So when we multiply both sides by 3, we have x over 3 times 3 is greater than or equal to 8 times 3. When we simplify this, we're going to get x is greater than or equal to 8 times 3 is 24. Again, we cannot leave our answer like this. It must be represented as a solution set. Now you guys can tell me the answer. The set x is such that x is greater than or equal to 24. Now here's another way we can solve linear inequations. We can solve linear inequations by dividing both sides by the same positive number. For example, we have 3x is less than or equal to 9. Dividing both sides by 3, we get 3x over 3 is less than or equal to 9 over 3. Now when 3x is divided by 3, we get x, and when 9 is divided by 3, we get 3. So we have x is less than or equal to 3. Now once again, we must represent our answer as a solution set. Hence, the solution set is the set x is such that x is less than or equal to 3. Here are two to try. Solve the following inequations. So here we have 5x is greater than or equal to 45. Now we are going to solve this linear inequation by dividing both sides by 5. When we do so, we get 5x divided by 5 is greater than or equal to 45 divided by 5. Now when we simplify this inequation, we get x is greater than or equal to 9, because 5x divided by 5 leaves us with x, and 45 divided by 5 leaves us with 9. And of course, our answer is always represented as a solution set. So we have the set x is such that x is greater than or equal to 9. Let's have a look at our second example. So here we have 3x is less than or equal to 12. Now we're going to solve this linear inequation by dividing both sides by 3. So when we do so, we get 3x divided by 3 is less than or equal to 12 divided by 3. Now, when we simplify this, we get x is less than or equal to 4, because 3x divided by 3 leaves us with x, and 12 divided by 3 is 4. And of course, we must represent our answer as a solution set. So we have the set x is such that x is less than or equal to 4. So guys, the fun continues. I don't know if you realize, but we've been talking a lot about multiplying by the same positive number as well as dividing by the same positive number. And I know what you're thinking. What about negative numbers? So here's something for that. If an inequality is multiplied or divided by a negative number, then its truth is changed. What do we mean by its truth is changed? Well, given that the statement negative 4 is less than 2 is true, and we can represent that on our number line. Now we know that the number line increases in the right direction, okay? So here we have negative 4, and here we have 2. So it is clear to see that indeed negative 4 is less than 2 when we look at our number line. So by multiplying both sides by negative 2, we get negative 4 multiplied by negative 2 is less than 2 multiplied by negative 2. Now when we simplify this, we get 8 because a negative number multiplied by a negative number produces a positive number. So that's why we have negative 4 multiplied by negative 2 to give us positive 8. And on the right hand side, we have 2 multiplied by negative 2 giving us negative 4 because a positive number multiplied by a negative number produces a negative answer. But is 8 less than negative 4? No, that is incorrect. So that's what we mean by its truth is changed. When we multiply an inequality by a negative number, its truth is changed. And we see that here because there is no way that 8 is less than negative 4. However, 8 is greater than negative 4. And that is correct. And we see that on our number line here. So here we have 8 and negative 4. And remember, our number line increases to the right. So the numbers get bigger and bigger as we go to the right. The numbers get smaller and smaller as we go to the left. So to the right we have 8, and to the left we have negative 4. So it's clear to see via our number line that 8 is indeed greater than negative 4. So let me ask you this question. Do you see a difference between our incorrect statement and our correct statement? And the answer is yes. We see that in the incorrect statement, we have our less than symbol, and in our correct statement, we have our greater than symbol. Now back to the incorrect statement. We have 8 is less than negative 4. And remember I said that is false because negative 4 could never be greater than 8. And we explained that on the number line. Now, in order to make that statement correct, we have to change our symbol to the greater than symbol. So now our correct statement reads 8 is greater than negative 4. And of course, we have our number line to support this statement. Here's another example. Given that the statement 8 is greater than negative 4 is true, dividing both sides by negative 4, we get 8 divided by negative 4 is greater than negative 4 divided by negative 4. When we simplify this, we have negative 2 is greater than 1. Does this look correct? No, it doesn't. This statement is incorrect. However, negative 2 is less than 1. That statement is correct. So here we see the difference between those two statements. We have a change in our symbol from the greater than symbol to the less than symbol. So here we have negative 6x is less than or equal to 18. And we're going to solve this linear inequation by dividing both sides by negative 6. When we do so, we get negative 6x divided by negative 6 is less than or equal to 18 divided by negative 6. When we simplify negative 6x divided by negative 6, we get x. And when we simplify 18 divided by negative 6, we get negative 3. Now we reach the point of what sign comes here, or for a better word, what symbol comes here. Think about it. I'm hearing murmuring. That means you're thinking. So remember we said the truth of an inequality is changed when we divide by a negative number. Now, in order to maintain truth, we are required to flip the sign. So therefore, the symbol that goes here would be our greater than or equal to symbol. So our answer reads, x is greater than or equal to negative 3. Now remember, we can't leave our answer like this. We must represent it as a solution set. And you guys definitely know how to do that by now. So we have the set x is such that x is greater than or equal to negative 3. Okay, so here we have another example. Y over negative 2 is greater than 11. Now we're going to solve this linear inequation by multiplying both sides by negative 2. When we do so, we get y divided by negative 2 multiplied by negative 2 is greater than 11 multiplied by negative 2. Now when we simplify this, we get y. And when we simplify this, we get negative 22. Again, we reached a point where we ask ourselves, what symbol goes here? Now, like I said, remember we said that when we multiply an inequality by a negative number, its truth is changed. Now, in order to maintain that truth, we must flip our symbol. So, what symbol goes here? Yes, you have it correct. The less than symbol. So now we have the statement y is less than negative 22. Now again, we must represent this answer as a solution set. So say it with me. The set y is such that y is less than negative 22. And here we have it. So here's something for you to do. Recall and write the 5 ways we can solve linear inequations. Read with me. 1. We can add the same quantity to both sides. 2. We can subtract the same quantity from both sides. 3. We can multiply both sides by the same positive number. 4. We can divide both sides by the same positive number. And 5. If we multiply or divide an inequality by a negative number, then we must maintain its truth by changing the symbol. Now, when we say change, we don't mean change it to an equal sign. We simply mean just flip the symbol. This brings us to the end of solving linear inequations part 2. How do you feel about what you learned in this lesson? I trust that you feel accomplished because you can not only solve linear equations, but you can also solve linear inequations. Thanks for joining today. See you next time on Spice Math.
That's right. You won't believe it's just math. Come on. You won't believe it's just math.